So let's suppose that at an initial time of t equals 0 seconds, a carousel is given a constant angular acceleration of 0.1 rads per second squared. Now initially the carousel's angular velocity is 0, but it increases over a time interval of 8 seconds. And at the 8-second mark, we want to calculate 4 things. A, the angular velocity. B, the linear or translational velocity of an object found at a 3-meter mark from the axis of rotation. C and D, the tangential acceleration and radial acceleration at the same exact point as in part B. So let's begin with part A. So let's recall the relationship between our angular acceleration and angular velocity of a rotating object. So the angular acceleration is equal to change in our angular velocity divided by change in time. The change in time is simply 8 seconds because our initial time is 0 seconds and our final time is 8 seconds. Now we know initially the angular velocity is 0, so all we're looking for is the change in our angular velocity, and we know what our angular acceleration is. That's simply 0.1 rads per second squared. So we rearrange this equation and bring the change in time term to the left side, so we get change in time multiplied by our angular acceleration is equal to our change in angular velocity, what we're looking for. So we plug in our two values, our two knowns, 8 seconds times 0.1 rads per second squared, and we get 0.8 rads per second is our angular velocity after 8 seconds. Now, let's move on to part B. So we want to find the linear velocity of the object at a point 3 meters from the axis of rotation, from the center of our carousel. So recall the relationship between velocity and angular velocity. So velocity or linear velocity is equal to the product of the angular velocity and our radius from that point, 3 meters, to our axis of rotation, which is 3 meters. So we see that velocity is equal to 0.8 times 3, and that gives us 2.4 meters per second. Now, the omega, our angular velocity, is identical to the one obtained in part A. Now let's move on to part C. We want to find the tangential acceleration of the object at the same exact point. So let's recall the formula for tangential acceleration. So it's equal to the derivative of our instantaneous velocity with respect to time. And recall that velocity is equal to our omega, angular velocity, times our radius. So we take this and plug it into the V, we get the following result, and recall that d omega divided by dt is simply our alpha, our angular acceleration. So we simply plug in our 0.1 rads per second squared, we plug in our 3 meters, and we obtain 0.3 meters per second squared is our tangential acceleration. Now, what about part D? What exactly is the radial or centripetal acceleration of an object found 3 meters away from the center of the carousel, from the axis of rotation? So recall the formula for radial acceleration. Radial acceleration is given by v squared divided by r. Now v we found in part B, it was 2.4 meters per second. And r we found, or r is actually given, that's 3 meters. So 2.4 meters per second squared divided by 3 gives us 1.92 meters per second squared. So this is the magnitude of our radial acceleration, 1.92 meters per second.